This is how Newton's three laws work in hockey. Every object will remain at rest or in motion in a uniform line until compelled to change its state by the action of an external force. Notice how the player is going and then stops himself with the skate? That is a prime example of Newton's first law, inertia. Watch the circled player for a moment.
Hemmerling in front. Hemmerling gets it to Mietten and a shot save. Rebound is loose in front.
Do you see how he stopped himself? Let's watch it back. If you watch closely, you notice how he's going and then stops himself and then starts running again. Watch it here again to see how he goes, stops, and then goes again. He's able to move like that because of friction. The friction of his skate on the ice causes him to go forward, which is part of hockey. Acceleration of an object is directly related to the net force and inversely related to the mass. Watch as these two players run into each other. Did you see that the one in yellow didn't have to apply much pressure? That's because he has more mass than the opponent. Focus on the circled players and watch as they fall. See how one falls and one just stumbles? Watch it again here, but slower. This happens partly because of their mass and velocity, and the other part because of their momentum, which in turn uses the law of conserving momentum. For every action, there's an equal and opposite reaction. This player runs into the wall and then jumps back, which is showing Newton's third law. An example to keep in your mind is you are pushing on the wall just as hard as it is pushing on you. Watch it here with two NHL players. This might be hard to capture, but watch as the people circled collide. Let's replay that. See how they bounced off of each other? No? See it again. This part really shows the collision that they're having, which is called elastic. They bounce off of each other because they are pushing on each other just as hard as the other one is pushing onto them. And that's all thanks to Newton's third law.